solving a system of 3 linear equations. So there are 3 basic steps that we can use for solving these types of problems. Step 1 is to group the equations into 2 pairs and use the addition method to eliminate the same variable from each pair. Step 2 is to pair the results from step 1 and solve the system using the method of addition. And step 3 is to substitute the results from step 2 into any one of the original equations and solve for the third unknown variable. So let's do an example. We have 3 linear equations. We have x plus y minus 2z equals negative 9, 3x minus y plus z equals 13, and 2x plus y plus 4z equals 17. So step 1 tells us to group the equations into 2 pairs so that we can use the method of addition to eliminate the same variable from each pair. Okay, so we can take this first equation and group it with the second equation. We can take the first and group it with the third, or we can take the second and group it with the third. So let's look at the first two. If I group those together and add them, I can eliminate the y variable here. Right? When I add these two together, I have positive y minus y, which equals 0. If I group the second and the third equations, I would have the same situation. I'd have negative y plus y, add those together, I get 0. So I can eliminate the y variables by doing that grouping. So let me do that. Let me write the first and second equation. X plus y minus 2z equals negative 9. X plus y minus 2z equals negative 9. And 3x minus y plus z equals 13. 3x minus y plus z equals 13. Okay? And now let me group the second and the third equation together. So I have 3x minus y plus z equals 13. 3x minus y plus z equals 13. And 2x plus y plus 4z equals 17. 2x plus y plus 4z equals 17. So now I want to add the equations together, each pair, to eliminate the y variable. So I have x plus 3x is 4x, y minus y is 0, negative 2z plus z is negative z, and 13 minus 9 is 4. Now let me take the second pair. 3x plus 2x is 5x, negative y plus y is 0, z plus 4z is 5z, and 13 plus 17 is 30. And notice that I can simplify this equation. Right? I can divide every term by 5. Whatever I do to one side of the equation, I have to do to the other side so that the equation remains equal. Okay, so let me divide every term by 5. So these 5's cancel. I have x plus, these 5's cancel, I have z equals 30 divided by 5 is 6. Okay, so now I've completed step 1, right? I've grouped the equation into 2 pairs and used the addition method to eliminate the same variable from each pair. So now I move to step 2. Step 2 says to pair the results from step 1 and solve the system using the method of addition. Okay, so let me take this equation and solve the system of equation using the method of addition. Okay, so I have 4x minus z equals 4. And I have x plus z equals 6. And let me add those equations together. 4x plus x is 5x. Negative z plus z is 0. 4 plus 6 is 10. Divide both sides by 5. These 5's cancel. I have x equals 10 divided by 5, which is 2. So there's my x term. Now let me get my z term. The way I do that is to take either of these two equations and plug in x equals 2 into the x variable and solve for z. So I'm going to take the second equation. X plus z equals 6. I have x plus z equals 6. And I want to solve that for z. So I subtract x from both sides. Right? X minus x equals 0, leaving me with z on the left side. And then I have negative x plus 6 on the right side. So I have z equals negative, and here I want to plug in my x equals 2 plus 6, and I have z equals negative 2 plus 6, which is 4. Okay, so I've completed step 2. I've solved the system using the method of addition. Okay, so I've got my x equals 2, my z equals 4, so now I need to determine my y variable. So that's step 3. It says substitute the results from step 2 into any one of the original equations and solve for the third unknown variable. Okay, so I'm going to take the first equation. I could take either or any of the three equations. I'll just take the first one because this looks fairly straightforward. I have x here by itself and y by itself. Okay, so let me take x plus y minus 2z equals negative 9. X plus y minus 2z equals negative 9. And plug in x equals 2 and z equals 4. So for x, I plug in 2 plus y minus 2 times, for z, I plug in 4 equals negative 9. So I have 2 plus y, negative 2 times 4 is negative 8, which equals negative 9. I have 2 minus 8 is negative 6, so I have y minus 6 equals negative 9. Add 6 to both sides. Negative 6 plus 6 is 0, leaving me with just y on the left side. Negative 9 plus 6 is negative 3. So I have my x, my y, and my z. So I write my solution as x equals 2, y equals negative 3, and z equals 4. And that is your final answer. I hope that helps.